Dear students, now today we are going to discuss about the Fourier series. The Fourier series, this is very interesting branch of mathematics, applied mathematics. You know, there are two very important function in trigonometry, that is sine function and cosine function. The beauty of these two functions are they look alike, but they are entirely different. Then Fourier, what he did, he has combined both the functions sine and cosine, and the combination of sine and cosine is known as Fourier series. So let us look what is detailed in the Fourier series. If this most important phenomena is studied in the domain of engineering and science are periodic in nature. For instance, current and voltage in an alternating current circuit, these periodic functions could be analyzed into their constituent component, fundamentals and harmonics by a process called Fourier series. So as I said, the combination of sine and cosine, because you know both the function are periodic function, and after a certain period, let us say in case of sine x, the period of sine x is 2 pi, and after 2 pi again and again you will get the same pattern of the signal or graph. A Fourier series is an expansion of a periodic function fx in terms of an infinite sum of sine and cosine. Fourier series makes use of the orthogonality relationship of the sine and cosine function. Now, all these waveform, you can say, you have already seen in different books. These waveform, they have the particular name also. I have collected this okay, you have to look this all together. Okay, this waveform is called this square wave. Just you look, okay, this is square wave. So this waveform is called square wave. This is the sawtooth wave. You have seen in many places, especially in the wood cutting shops, you have seen this kind of the waveform, that is called the sawtooth waveform. And then this is the triangular wave. So triangle wave, this is called the triangle wave, and this is semicircle wave. So this is called semicircle wave. Okay, so now a function is periodic. If you go through the book, then a function is periodic of period k if f of x plus k is equal to fx for every x in the domain of f. The smallest positive value of L is called the fundamental period. Like in case of sin x, you know the fundamental period is 2 pi. Otherwise 2n pi you can say the period, but putting n is equal to 1, the fundamental period is 2 pi. The trigonometric functions sin x and cosine x are examples of periodic function with fundamental period 2 pi, and tan x is periodic with fundamental period with pi. A constant function is a periodic function with arbitrary period L. So this is the case of periodicity, and what do you mean by the periodic function. But there is a special characteristic in the study of the function. The function is under the two categories, you can say even and odd function. A function fx is said to be even if f of minus x is equal to fx. The function fx is said to be odd if f of minus x is equal to minus fx. Graphically, even function have symmetry about the y-axis, we have to remember, and whereas the odd function have the symmetry about the origin. The Fourier series, there are both type of even and odd Fourier series. If you look at the graph gently, then the graph look like this. As we discussed, the even function, that is function are symmetry about the y-axis, it is very much clear here, and the odd function have the symmetry about the origin, it is also very much clear here, and this is neither even nor odd function. Okay, so sin x is odd function, cosine x is even function. You can see the complete picture of sin x and cosine x. We also know the product of two odd function is even, the product of two even function is odd, and the product of even function and an odd function is odd. So from the book we know this. Now, so there are certain more important facts. It means a representation in the form of trigonometric series, that is a naught by 2 plus summation over n is equal to 1 to infinity a n cosine n x plus b n sin n x, was given by the French scientist J.V. Joseph Fourier in 1822. We may also define as the infinite trigonometric series a naught by 2 plus summation over n equal to 1 to infinity n cosine nx plus summation over bn sin nx is called Fourier series of fx of period 2 pi, defined in the interval x lying between k to k plus 2 pi if the coefficient an and bn are given by an is equal to 1 by pi k to k plus 2 pi fx cosine nx dx, where n varies from 0 to 1 2 3 and bn is 1 by pi k to k plus 2 pi fx sin nx dx, and an and bn are called the Fourier coefficient of fx 1 and 2 called the Euler's function. So this an and bn are also called Euler's function. The condition under which it happened is called Dirichlet condition. So let us look what is the Dirichlet condition. Here the same thing we may write in the form of minus pi to pi also. What is an, what is bn, we may define like this. So you look the Dirichlet condition. The Dirichlet condition, Dirichlet was a famous German mathematician. He is famous for his contribution in Fourier series analysis. In 1829, he provided the precise condition under which the Euler Fourier series exists for a periodic signals, and here if a function fx defined within the interval c to c plus 2l, the following condition must be satisfied. Fx is defined and single valued. Fx should be continuous or finite discontinuity in the corresponding periodic interval, and fx and f dash x are piecewise continuous. So these three conditions are known as Dirichlet condition. We have to remember these three conditions. In addition to the above, and as discussed here in this presentation, at least you read yourself with the convergence of Fourier series. This is also very important. Then all the product formula of like twice sine A sine B, twice cosine A cosine B, twice sine A cosine B, that may be useful here, and including these values you might be remembered from your previous classes. Sine n pi is 0, sine 2 n pi is 0, sine 2 n plus 1 pi by 2 is minus 1 power n. This will vary upon n. If n is even, the value is plus 1. If n is odd, then value is minus 1. Similarly here, cosine n pi is minus 1 power n. It will be hugely used during the discussion of Fourier series. Cosine n plus 1 pi is minus 1 power n plus 1. And cosine n minus 1 pi is minus 1 power n minus 1. Cosine 2n plus 1 pi by 2 is 0. Okay, so this is the base of the Fourier series. Now you can attempt the problem. Obtain the Fourier series for fx is equal to pi minus x by 2 whole square, where x is lying between 0 to 2 pi. It is given that fx is this. Then the Fourier series you can write like this, and now you have to evaluate a naught. A naught is 1 by pi 0 to 2 pi fx dx. Similarly an and bn. So a naught, after putting in place of fx pi minus x whole square, pi minus x by 2 whole square dx, after evaluation you will get the value, and the value will be a naught will be and similarly you can evaluate the an. Then after evaluation you will get an may be 1 by pi 0 to 2 pi pi minus x by 2 whole square cosine nx dx, and an will be 1 by n square. You check yourself, and then bn similarly you can calculate, and bn will be 0. Then after putting all the values here, the required Fourier series will be pi by 12 whole square plus summation over n is equal to 1 to infinity cosine nx by n square. I have left several steps during the computational steps just for your practice. Just you do the practice, and then you correlate your Fourier series should be pi by 12 whole square plus summation over n is equal to 1 to infinity cosine nx by